Hi dear students, in this video we are discussing the questions from previous year's Neet exams from the chapter Solutions which were asked especially from 2020 to 2024. You please listen. Question number 1. The mixture which shows positive deviation from Raoult's law is option number 1 chloroethane plus bromoethane, option number 2 ethanol plus acetone, option number 3 benzene plus toluene, and option number 4 acetone plus chloroform. We know the solutions formed by two volatile liquids, say for example capital A and capital B, can be classified into three types. First one is ideal solutions. Second one, non-ideal solutions showing positive deviation from Raoult's law. Third one, non-ideal solution showing negative deviation from Raoult's law. The intermolecular force of attraction present in the solvent A, which can be represented as AA force of attraction, that in B can be represented as BB force of attraction, and that in solution can be represented as AB force of attractions. For ideal solutions, these three force of attractions, that is AA, BB and AB intermolecular force of attractions must be same. For positive deviation, AB force of attractions are lesser than both AA and BB force of attractions. For negative deviation, AB force of attractions are greater than both AA and BB force of attractions. Here in this question, option number 1 and option number 3 form ideal solutions because the components have identical size, shape and polarity. Therefore, AA, BB and AB force of attractions will be same. Option number 2 shows positive deviation from Raoult's law and option number 4 shows negative deviation from Raoult's law. So here the answer is option number 2. Now question number 2. The freezing point depression constant, that is Kf of benzene, is 5.12 Kelvin kilogram per mole. The freezing point depression for the solution of molality 0.078 m containing a non-electrolyte solute in benzene is, in bracket round off to 2 decimal places. Option number 1 0.6 Kelvin, option number 2 0.2 Kelvin, option number 3 0.8 Kelvin and option number 4 0.4 Kelvin. Listen, here Kf of benzene is given as 5.12 Kelvin kilogram per mole. Molality of the solution small m is equal to 0.078. We need to find out the depression freezing point of the solution delta Tf. We know delta Tf is equal to small I into Kf into small m, where small I is called Van Hoff factor. For non-electrolytes, small I is equal to 1. Substituting these values, delta Tf is equal to 1 into 5.12 into 0.078, that is equal to 0.4 Kelvin. So here the answer is option number 4. Now question number 3. If 8 gram of non-electrolyte solute is dissolved in 114 gram of normal octane to reduce its vapor pressure to 80%. The molar mass in bracket gram per mole of the solute is, given that molecular mass of normal octane is 114 gram per mole. Option number 1 40, option number 2 60, option number 3 80 and option number 4 20. Listen, here mass of solute WB is given as 8 gram. Mass of solvent WA is equal to 114 gram. Lowering a vapor pressure, that is P0A minus PA, that is equal to 100 minus 80. We need to find out the molecular mass of solute. We know the relative lowering of vapor pressure P0A minus PA divided by P0A is equal to WB into MA divided by WA into MB. That is 100 minus 80 divided by 100 is equal to 8 into 114 divided by 114 into MB. That is 20 divided by 100 is equal to 8 divided by MB. So molecular mass of solute MB is equal to 8 into 100 divided by 20, that is equal to 40. So here the answer is option number 1. Then question number 4. Isotonic solutions have same option number 1 vapor pressure, Option number 2, freezing temperature. Option number 3, osmotic pressure. And option number 4, boiling temperature. See, by definition, two solutions having same osmotic pressure are called isotonic solutions. So here the most appropriate answer is option number 3. Now question number 5. The following solutions were prepared by dissolving 10 gram of glucose in bracket C6H12O6 in 250 ml water in bracket P1, 10 gram of urea in bracket CH4N2O in 250 ml water in bracket P2, and 10 gram of sucrose in bracket C12H22O11 in 250 ml water, which is P3. The right option for the decreasing order of osmotic pressure of these solutions is option number 1, P2 is greater than P3 is greater than P1. Option number 2, P3 is greater than P1 is greater than P2. Option number 3, P2 is greater than P1 is greater than P3. And option number 4, P1 is greater than P2 is greater than P3. Listen, here in this question, 3 different solutions are prepared by dissolving 10 gram each of glucose, urea and sucrose in 250 ml water. Now we can calculate the number of moles of solute present in these solutions. That is, number of moles of glucose is equal to its weight divided by molecular mass, that is equal to 10 divided by 180, that is equal to 1 by 18. Number of moles of urea is equal to 10 divided by 60, that is equal to 1 by 6. Number of moles of sucrose is equal to 10 divided by 342, that is equal to 1 by 34.2. Here in these solutions, number of moles of solute is maximum in urea, then glucose and then sucrose. We know osmotic pressure is a colligative property. Therefore, it is directly proportional to the number of solute particles. Therefore, the osmotic pressure is maximum for urea solution and then glucose solution and then sucrose solution. That is, P2 is greater than P1 is greater than P3. So here the answer is option number 3.